A quick review over your 3.2 since we didn't meet Wednesday. Really important that you kind of remember some of those things about parabolas. Remember, especially for the right-hand side of these graphs. If the leading term that you have, right, it's going to be the one that has the largest exponent. If the leading term is positive, then the right-hand side is going up, which relates back to those parabolas, right? It's the exponent part of these terms that will tell you what the left-hand side is doing. If it's an even exponent, it's going to copy the right-hand side. So remember, that's why I say even Steven. It just does what the right-hand side is doing. It's kind of like the little brother. The exponent is doing whatever big brother is doing, right? If the coefficient is negative, the right-hand side was going down. So again, because it's an even exponent here, it copied it, it did the same thing. Over here, this one, it's positive, but because it's an odd exponent, the left-hand side was doing the opposite, the odd man out memory device that I use. So it's going to do the opposite of whatever the right-hand side is doing. Because the right-hand side is going down with the negative leading term, and that means if an odd exponent, it's going to go up. Just going to do the opposite direction. Do you guys get that memory device? Are you kind of picking up on that? It's pretty easy if you remember the stuff about parabolas. And if you just know that that is still just talking about the right side only. When I say right side, the right-hand side of the y-axis, then you just have to learn the exponent part to understand the rest of that. If it's an even exponent, it's the same. Odd exponent, it's the opposite. I said that like 5 times in a different way, but there we go. I'm not going to go over all those that we went together. Another thing that we learned was we can look at the leading exponent and figure out how many terms a graph has. So like if the biggest is 3, we just subtract 1 from it. So we know that there's 2 turning points. This over here, I was just showing you, remember when we talked about parabolas, the leading exponent would have been like a 2, right? So 2 minus 1 is 1. So that's why it only turned 1. That's all that was. We did learn about even and odd powers. It really goes, in my opinion, hand in hand with X and Y intercepts, which is a big part of choosing the right graph that we learned. But even and odd exponents tell you if it's going to turn at the x-axis, so that's called intersecting but not crossing, or if it's going to cross it. So when you're asked to sketch a graph, which you will be, you do need to understand that rule for that reason. So if it's an odd exponent, it will cross it. I don't have a memory device for that, so maybe you have to make up your own to know between the 2 different things. If it's an even exponent, that's when it's turning. And so it's going to intersect but not cross at those points, which we will learn are called the x-intercepts. Okay, so I just kind of give you a quick sketch of what that means. So that's why you need to know that rule too, because if you're just doing a hard sketch of it, you need to know, am I going through that and then turning, or am I turning at the x-axis? And then we did talk about x-intercepts. X-intercepts are just very similar to when you were solving quadratic equations, right? But we are now, so you're finding those values for x. We do it by factoring. If you didn't notice, you can solve for these by factoring. So we set our y as our 0 part. I went ahead and just put y there, but remember we would always put 0 in that spot when we're doing the quadratic equation stuff. I'm just going to put a 0 in red above it. And then we just factored it, and we set those factors equal to 0. So x-intercept means you put a 0 in for your y value, and so those x's all have a 0 with their y for there. It's really blinking today. Sorry, guys. It's also blinking on my Zoom meeting, but all of those y parts for your ordered pair will be a 0. The x's that you found are the x parts. So that's where it's going to either be turning or crossing, which all of those were odd exponents, so it's all crossing, right? And then the y-intercept it shares up here too. They're both going to be crossing the origin, but that's when you just put 0 for your x and solve And so we did that with our x, and we found that y was 0. It's not always 0 though. Your y-intercept might be, 15, depending on if you have a constant in that polynomial. Okay, so that's a review of that. Let's go do some additional examples that you're going to see in your homework. That'll be a lot more like what you're going to look at, not just like our notes. Okay, I mean, they're like our notes, but this is how they'll read. So number 1 says, examine the leading term and determine the far left and far right behavior of the graph of the polynomial function. So remember, the first thing you need to do is just be sure it's in descending order, or just look for the term that has the biggest exponent. You don't necessarily have to rewrite it if it's not in descending order, but your leading term would be the term with the biggest exponent, which it is already in that order. So I have 5x to the 4th. So remember, we always identify the right-hand side because it relates to something we already know, and it helps us determine the left-hand side really easy with the way that we learned it. So since my leading coefficient in this problem is positive, the right-hand side's doing what? It's going up. I heard somebody say it. Good. So remember, this is going to talk about your right-hand side. Your exponent tells you your left-hand side. Since this is even, what is it doing? It's going up because it's an even number. Remember that terminology, even Steven. So we know it's going up. It's going to do the same thing. Number 2 is just a repeat. It's just that there's different things with it. It does select all that apply. Some of these are going to be multiple choice on your web assign, so just be sure you're reading them carefully. And they do read the far left part first. So go identify them both first and then read them, because we identify when we're finding it our right-hand side first. So in this one, my leading term, it's in descending order, so it's not like it's playing a trick on us. Our leading term is a negative 5x to the 5th. So this time it's a negative, so we know the right-hand side's going down. And then my far left, my exponent is an odd number. So what is it doing? Right, it's going to do the opposite because it's an odd exponent. So if you need to write some of those things there to help you determine those things, it'll help a little bit. Hopefully you're already picking up on it though. Number 3, there's a question that says the following graph is the graph of a fourth degree polynomial function. What does the far left and far right behavior of the graph say about the leading coefficient? So we can see what's happening here. We know that the leading coefficient, if the right-hand side, because that's what determines its sign, right? My far right is going down. So what does that mean about the leading coefficient? It's negative, right? So we know we have a negative leading term or coefficient, however you want to write it. That's really all you'll be looking for there, and that will probably be not probably, it is a multiple choice, so you can read through their verbiage and just pick the best answer that fits that. And we knew that the exponent was even just because the left-hand side was going down, but they weren't asking you about the left-hand side really. They were just trying to ask you, like, it says, what does it say about the far left and far right behavior? But all that's already going to be together, and really all we had to identify was the right-hand side. So number 4, there's a question that's read like this. We didn't really do one exactly like it in the notes prior to this number 4. It says find the real zeros. I know it's blinking. I'll pause a minute. So it says find the real zeros of each polynomial function by factoring. The number in parentheses to the right of each polynomial indicates the number of real zeros of the given polynomial function. That's just how it's read in your web assign. But so if we're talking about real zeros, remember this section really goes hand in hand with solving quadratic equations. And we're going to call the solutions to those when we factor them, we would say solve for x, right? And x equaled 2 or 3 or 7, I don't know. But we're going to refer to them now as real zeros. And that will make a little bit more sense as we start our topic 3.3, why it's called real zeros. So here, can we factor this? Yes. Remember, this would be like saying 0 equals, how do I split apart x to the 4th? X squared. And I'm using same signs to make a negative 37. So I'm going to have to use the factors 1 times 36, and they would both have to be negative, right? So we have a -1 and a negative 36. There's technically 2 ways to go solve for those x's. We're just solving for x, even though it says go find the real zeros. That's what those real zeros are, whatever the x values were. There's 2 ways that you could do it. Both of these technically could factor more. You're going to get real numbers in all of these. These are not going to have radicals like quadratic equations did. Or a quick way, since it's a perfect square, is we could still use our square root property if you want. Maybe you remember that. We would add 1 to move that over. So x squared equals 1. So remember, there's 2 solutions for this part. If I take the square root, if I find x, what's the square root of 1?
Positive negative 1.
Right, positive and negative 1. And then here we would be moving our 36 over. So we'd have x squared equals a positive 36. And then finding what x is instead of x squared, we would take the square root, we would say x equals 6 and negative 6. So these are considered real zeros. What this means as we get into it a little bit further is if you were to go divide or set this up as synthetic division, and if you were going to use 1, -1, 6, -6 as any of the numbers out there to do synthetic division, you will get a 0 as a remainder because these are considered factors of this polynomial. This one we can factor, like we could have said x minus 1, x plus 1, x minus 6, and x plus 6. That's an ugly x, but basically what we're learning to do with this stuff is sometimes you're going to look at a polynomial and it's going to basically be impossible for you to actually use our normal factoring methods that we've done and factor it like we could one like this. This one we can factor it. We have that capability. And you've set all those factors equal to 0 and you go find them. So when it asks you the real zeros, you're just going to be entering these numbers. It's not an ordered pair. It's just those values. Those values, again, if you were to use synthetic division in that polynomial, you would not have a remainder, right? It would be 0. What this means. Kind of pulling it all together with some stuff that you already know so that you know that it relates. But there's going to be some polynomials, and we did this one so that you would be able to maybe do some of your homework. Since we didn't get to finish this topic. It's going to be on WebAssign anyways. It says sketch the graph. Obviously, you can't sketch a graph in WebAssign, so you're actually picking the appropriate graph. But you should be able to sketch a graph. And the way to do that is to go through all those things that we learned about those behaviors of graphs. The biggest thing when you're doing your homework is to know your far left and far right behaviors and to be able to find your x-intercepts. And that's really what I hit on the hardest whenever we did this one example because of time. So these would be your x-intercepts and your far left and your far right behaviors that we talked about. A lot of times you'll be able to eliminate a couple problems or a couple of the graphs just because the far right and far left behavior isn't doing what it should do. So these two were, but then the way that we picked between the graphs was just looking at our x-intercepts. But we still need to kind of understand, I knew that this graph would have 2 turning points. Those are also things that we learn. So go ahead and identify that on this note, just to kind of add to it. We also knew our y-intercept. Just reviewing all the things that you know, because you do need to be able to remember all these things. How do I find the y-intercept if I needed to? What do I plug 0 in for in the equation?
X.
Right, we have p of x equals, we had x to the third minus 2x squared minus 15x. If you want to know the y-intercept, we can say p of x, sorry, it's blinking, it'll come back on. We could replace that p of x with y and just plug zeros in for the x values. Hopefully you kind of remember that when we learn to graph linear equations. But because there's not a constant, this one too, its y-intercept was 0, 0. You know, if there's a y-intercept, if there's like a minus 21 on the end, which I think there's one like that in your homework, you know that the y-intercept would be like 0, negative 21, right? It's going to be, it will cross the y-axis sometimes other than just the origin. And then the last thing that we did talk about were the odd and even powers. But all of these have odd powers because there wasn't like a something squared, right? So we knew that it was going to cross the x-axis. This is probably the one that is ignored the most, but it helps you when you're sketching your graph the best. But we don't really use it when we're doing multiple choice on our web assign. So it's easy to just kind of dismiss it like it's not important because all of them are already, you know, doing what, like, I don't think there's anyone that's like turning or crossing that you had to pick between. Okay, so let's do another one for practice. So this one would be a good example of why leading up into topic 3.3, we couldn't factor this one ourselves. So they have already factored it for us. Okay, we know that there's going to be 3 solutions for x, so that means 3 x-intercepts. In this case, 3 zeros. But they've already factored it for us, so that's really helpful. But to be able to determine our far right and far left behavior, let's go ahead and write far left over here and far right. What's the right-hand side doing? Up. And if you notice, all 4 of these are going up. So unfortunately, we can't really eliminate any of those yet. What's the left-hand side doing since that's an odd exponent? It's going to do the opposite. It's going to go down. So the far right is going up because it's a positive coefficient. But then it's the left-hand side, they're all going down because of that negative exponent. So we couldn't really eliminate any of those. So whenever we go find our x-intercepts, because it really is about the best one to use when you're doing picking a graph and not just sketching a graph, it's already in factored form for you. So you can take each of those factors, x minus 1 equals 0, x plus 4 equals 0, and x plus 5 equals 0. We can take all of those factors and go solve for x and find their x-intercept. So x would equal a positive 1. So its ordered pair would be 1, 0. What would the next x be?
-4.
-4, right? I don't really have the space because I switched it, so I'm not showing the -4, but remember you have to subtract it to zero it out. So we have -4, 0. And then this one would be x would also equal a -5, so -5, 0. So it's quite possible that from those 3 points, you could probably pick out the right graph. So let's go look and see what we have. Let's go look at this graph. 1, 0 is right here. So we know it's not that graph. That graph is not touching 1, 0. -4 or 1, 0. Let's do that again. Is here. The next one was -4, 0. So that's right there. So since it's not crossing that point, we know it's not that graph. Start again. 1, 0 is here. -4, 0 is right here. Looks like it's crossing there. And then -5, 0 is also right there. So you see how it's kind of doing a little loop above and down. So it's probably this graph, but just double check the 4th graph to be sure. 1, 0 is here. -4 is right here. but then they have 5, 0. They kind of throw that on there because what if you forgot to change your sign? So that one is not one of the intercepts. It would have been right here, right? So we know that's not it. This one would have a y-intercept that's not just the origin, right? Can you guys see that without having to do the math? So just like when you were using your slope-intercept form of an equation, your constant number was where you started your graph. That's the same thing here. Do you see how that's happening right here in that graph at -20? Mathematically, what you did for your y-intercept was you would have plugged 0 in for those numbers in the very beginning, 0 to the 3rd power plus 8 times 0 squared plus 11 times 0 minus 20. Kind of ran off, so all those things were zeros, so y would have been that -20. But the other two things that you didn't really need to know, I mean, we've already picked the appropriate graph, but how many turning points did that graph have? Let's just go over it. How do we know how many turning points a graph has? So we don't forget. What'd you say?
Track 1, 0, March 6.
Right, so 3 minus 1, we knew it just had 2 turning points. And you guys can see that just it turns here and here. That's what that means. And the last thing was odd and even powers that you learned. I'm just really going over all the different things that we learned up until the end of 3.2 about graphs. So we learned some more stuff in 3.3. But all of those had odd powers, right? Remember, there's an understood 1 there. Here there was an understood 1. And here there was an understood 1. So we knew that they crossed the x-axis at those x-intercepts that we found, right? At 1, 0, -4, 0, and -5, 0. So to me, these technically go hand in hand. It tells us if at those x-intercepts, if they're crossing or just simply turning, and that's how you'll be able to do your own sketch. It doesn't have to be an exact graph, but if it was an even power, maybe a factor that repeated twice, right? You would need to show that it's turning at that point and not going through. But your graphs aren't going to be that tricky. And so again, I know that we don't really pay attention to this concept that we learned in 3.2 quite as much. So that is all of the 3.2 stuff.